So let's go ahead and look at our template library. And in the ODOT template library, under ODOT Backbones Undivided Highways, I added two categories here. The full depth pavement, or the templates that were already in there for full depth, and then the widening and resurfacing category is a new category with a few new templates for overlay projects. So let's take a look at these templates, and I'll just use the first one to talk about most of it, and then we'll summarize the other three. So this one is set up for widening and resurfacing. So I've got a surface course, 1.25 inches, an intermediate course, 1.75 inches, and then I'm looking for a saw cut line on the right and a saw cut line on the left. And I've got two base courses from the saw cut to the edge of pavement, and then my shoulders. If I look at the definition for these points for the saw cut line, you can see it's just a slope constraint from my PGL, a standard 1.6% slope. And I've got it horizontally defined 10 feet to the left of my PGL. But I've got a style constraint defined also. So that imported profile, or that imported saw cut line, it's going to look for that style that was assigned to the saw cut line, and if it finds it, it'll match that for the offset value. So if you don't import a saw cut line, your offset here would control the location of your saw cut. If you do import one, it will search for that saw cut line offset and match that width. And the right side's defined the same way. The only difference is a negative slope from the PGL and a 10 feet to the right. Now my lane points are defined. The slope is defined as a vector offset between the PGL and the saw cut. So it's going to just continue that slope. So if I were to come in here and maybe test my constraints on the saw cut point, and let me reduce the exaggeration a little bit. So you can see it just maintains that vector offset for the slope out to that lane line. And you can see wherever it finds the saw cut, it's going to define the width of my proposed pavement there. Okay, the next thing we've got defined in here is two components for overlay or stripping. And let's talk about each of these components. The first one is right on the bottom of my intermediate course. And it's just a single purple line. And if I double click on it, I can open that component and take a look at it. So I have it defined as, or named as, a pavement leveling course. And this is a new type of component that was added to the software recently. So some of the different options here is I can define the behavior of this component with a top and bottom option and some thickness values. So I'm not going to necessarily talk about every option here, but just kind of summarize the main ones on how this is defined. So the top of this is defined to follow the component that it's constrained to. And you can see I have it constrained to the bottom of my two pavement layers that I'll be overlaying my existing with. And then the bottom option, I'm telling it follow the existing ground surface. And I can give it a component depth here, and that would come from the component down. I've got that set at 0, or I can give it a surface depth here, and I've got that set to 1 inch. So the bottom will follow my existing ground, and it will go down 1 inch below that. So what I'm going to end up doing is 1 inch of pavement planing, and then I'll have a leveling course that will come back and put that inch back in and level it out to the bottom of my pavement. So that's how that component is defined. The second one is my pavement planing. So if I double click on that, it's defined very similar fashion. The top option here, instead of following a component, is going to follow the surface. And the bottom will follow the surface, and I'll go down 1 inch here for my planing. And I have toggled on an option here to tell it this is a stripping component. And the only thing that really does is just in the earthwork estimate, it will treat that as a removable area. Now this second one could have been defined right up here on top of the leveling course. It doesn't really matter because I've told it to go find the surface. So I put it down here just so I didn't have so many overlapping components, and so it was easy to see that there was another component there. But it certainly could have been defined up here on top with that, and it'll go find the surface. So let's go ahead and test this just to look at the behavior. So I use the draw button to simulate existing ground, and as I move over you can see the white line represents the location of existing ground, or the top of my pavement. And you can see in purple my wedge course, the top of it follows the component that it was constrained to, and the bottom of it meets my existing ground. And then in orange I've got my my stripping component, and it's going to the top of that's going to follow the ground and then an inch below that. And the purple one actually overlaps that because I had set it to go an inch below the surface. So the orange one will represent that pavement planing, and then the purple one will actually be defined to fill that back in as far as the quantity values for those. Now the other three templates are just variations on this one. So I have a widening to the left, and I guess this one technically could be used for widening to either side with a saw cut line. You would just redefine the width of your right or left lane points, or have it go out and meet an imported graphic. So you can make those edits to the template if you need to. So the one that's widening to the left, from the PGL to the left, I have a point named left existing edge pavement, and if I double click on that, you can see I gave it a style constraint defining edge pavement. But you could edit that to be a saw cut line, so that could find a saw cut line if you wanted to change that style component that it's looking for. And then this is set at 24 feet. On the right side, I don't have any saw cut. It just goes right to the edge pavement and adds a new shoulder. So that's the difference on this one versus the first one, is there's no saw cut on the right side. And again, this could be either an edge pavement or a saw cut. And then the widening to the right is the opposite, no saw cut on the left, and I've got a point that could be used as the existing edge pavement or the saw cut location. And the last one is just an overlay with shoulders, and there's no saw cut line involved at all. It's just looking for that existing edge pavement. So there's 4 templates there to use as examples. Get you started maybe on some widening and resurfacing. You can edit these to meet your needs. One last thing I want to note on these is I did not define them with the full super elevation for our shoulders. You can see in the note or the description I have a super elevation less than or equal to 6%. So what that means, if I test my constraints here on my shoulder slope, you can see as I go steep, it follows my pavement slope. So the low side of super, it would work fine. But on the high side of super, if I get up above 6%, you can see it keeps rolling up. So there's a rollover lock assigned, but I did not put all the parameters for the break of our high side of super into these templates. So that's something that could be done at a future date, or some new templates made with all the shoulder break conditions. So I just thought I'd mention that that's the way these templates are configured for our examples. So what I'm going to do is in the project templates folder, I'm going to copy this widening and resurfacing template, and then I'll rename this according to my center line, CLPS 185 overlay and widening. And that's the template I'm going to use to run on my cross section. Not going to make any edits to it. You know, of course, normally you would come in and add some in conditions to that, but for the purpose of this, I'm just going to focus on the pavement, so I'm not going to worry about adding any in conditions.